on NPI.
On NPI, brought to you by Digi-Key and Adafruit. Thank you, Digi-Key. Every single week, Adafruit and Digi-Key bring you the newest product introduction. This week, it's Sensirion, the sensor company. Lady Ada, what is this week's Eye on NPI?
Glad you asked. This week's Eye on NPI is the STCC4. This is a new CO2 sensor, a carbon dioxide sensor from Sensirion. We love Sensirion. We've covered them quite a bit. This one, the STCC4 sensor, is unbelievably small, only about 3 by 4 by 1.2 millimeters, easily pick and place, low cost, uses thermal conductivity to measure CO2. Pretty good accuracy, plus or minus 100 ppm. It's calibrated in factory, good for 400 to 5,000 ppm. So, basically for indoor usage. It's not designed for like scientific CO2 measurements, but it's excellent if you're like, hey, I want to measure the CO2 levels of my house or my school or my office. This builds off of Sensirion's, decades-long history in making amazing high-quality gas and air quality sensors. We've covered, every time they come up with a new sensor, we cover it because they're all like really good and people really like them. The SCD 40 and 41 was their acoustic, I want to say like thermoacoustic CO2 sensors, which, improved on the size and price of the SCD30, the NDIR, which is still like a very classic sensor people use. And of course, their gas sensors and their all-in-one environmental sensors. So, as I mentioned, the sensor that people have used for a really long time, and we stock a Breakout for, the SCD30, uses NDIR, like non-dispersive infrared, light measurements to do CO2 measurements. And this one is good for scientific. It'll actually measure like CO2 itself. They're, not inexpensive. They're like, about $30 a piece on Digi-Key. But they're through-hole solderable. It uses I2C. They're like really easy to use. There's tons of libraries. But they're really big. Like this is a very big sensor. And so Sensirion followed up only a couple of years ago with the SCD4X series, which you see kind of in the middle right there. And, what's interesting is CO2 sensing for environment. It's been used by HVAC people for a long time to keep track of, whether there's good air circulation. But basically, in 2020, CO2 became a way of measuring how good air circulation was for the avoidance of COVID transmission, because it seemed to be well correlated. If you had a lot of good fresh air coming in, the risk of transmission was reduced. And so schools and homes and offices started caring a lot about CO2 measurements. And Sensirion happened to be like right there with really good sensors. And, even though, we're not dealing with the same level of COVID transmission as we were before.
Or who knows?
Or who knows? People still do take CO2 measurements very seriously. First off, I definitely notice if CO2 is high in my room. Well, now I can measure it. Once it gets over 1,000, I'm like, oh, it's a little stuffy. And I'm like, right, let's open a window. But people may not notice it. I've had people take our sensors and do projects, and they're like, whoa, I didn't realize that in my basement where I work, I do electronics, it gets up to like 2,000, 3,000 ppm. And I'm like, yeah, you need to work on your air circulation. It's stuffy and you may not even realize it. So the more less expensive CO2 sensors, the better, because I think it does make a really big impact on people and animal health. Anyways, so the STCC is much, much, much smaller. It's not going to be the most precise, like it does use a different way of measurement, but it's definitely better than the equivalent CO2, the ECO2 sensors, which basically guess based on gas measurements using like MEMS heaters. So this their technique that they're doing is going to be a lot better. It'll actually get true CO2 measurements. However, it does expect you to have kind of classic air composition. Like it's not going to work in a scientific environment where the composition of the air, with CO2 and nitrogen and oxygen is out of kind of the standard composition that you'd expect for like human environment, right? So if you're doing that kind of scientific measurements, get the SCD30. Also, you do need to, like every CO2 sensor, it does have to be exposed once in a while to 400 ppm CO2, like outdoor air. It also does have a warm up of a couple hours. So, I mean, just like, there's an automatic self-calibration, which does expect, to correct for drift, you will need to have 400 ppm CO2. It basically means you have to open the window or door once in a while. Measurements are, right, so you can measure 400 to 5,000 ppm. That's basically indoor. I talked about the thermal conductivity thing. It's expecting 78% nitrogen, 21% oxygen, and then like 1% argon in order to measure the CO2 concentration. So like I said, it's for indoor, outdoor use in homes, offices, schools, etc. One thing that will greatly improve the quality of the readings, and the SCD30 has a temperature and humidity sensor built into it, and so does the Sen66, used for compensation. The STCC, to keep it inexpensive, does not contain the temperature humidity sensor that would be used to basically calibrate against the ambient air temperature humidity. So what you can do is there's 2 pins that have like a peripheral I2C connectivity, and you can connect an SHT 40, 41, 45. I think the 40 is plenty good, and it's very inexpensive. It's like $1 or $2. And it will automatically read the measurements from that sensor because they're both from the same company and knows the setup for it. And you can still read the temperature humidity through the STCC4. What's nice is that you don't have to like do the thing where you write the temperature humidity to the sensor. The sensor will like read those values when it feels like, oh, I need to recalibrate. So that's kind of nice. But you do have to buy those as a separate component. Fairly low power, in active mode, it's about 4 milliamps. But on average, given that you're only sampling every 10 seconds or so, it's about 500 microamps. Sleep mode is 1 microamp. You can measure, you can power it from 3 to 5 volts, as the VDD at the top there, and ditto for I2C. However, because if you're using the SHT4X as like the peripheral temperature humidity, and those are limited to 3.3, I would just say run the whole thing off of 3.3. You can. As people who've used Sensirion sensors are used to, there is I2C commands that you have to use to put it into mode. They do have an Arduino driver. They also have I think Python and like embedded C. But also the commands are very simple. It's not like there's some weird binary blob. You run the command, you read the data. I believe there's a CRC or something as well, and you get the results out. So they do document the entire command set. They can also get started very easily with the ready-to-go drivers. Available from Digi-Key, you can also get an eval kit for the CO2 sensor. What I like about this is like, boy, doesn't it look like an Adafruit sensor? Yeah, it's got the 4 mounting holes and the STEM QT / I2C, quick connector. I don't think they do need level shifting on there. They do have an SHT 40 or 41, as well as the STCC4 sensor and the breakout pads. So this is like ready to go instantly, and it's not too expensive. That's available from Digi-Key. But also, I designed a breakout board as well that'll come out with soon. So you can see the draft here. I added an SHT 41, but maybe I'll go with a 40. And then you can see the sensor at the bottom. They're very small, very compact, pick and placeable sensor. So I think this will be great for wearables or indoor monitoring. You don't have that big chunky SCD30 or the SCD4 that takes up a lot of space. This can fit pretty much any enclosure. And best of all, it's in stock and at a really good price. It's like, $5? Like maybe you can.
It's a good price.
$6 a piece. And you can buy it as little as quantity 1 from Digi-Key right now.
And that is Sensirion with the latest NPI from Digi-Key and Adafruit. See y'all next week. Thanks, Digi-Key.
On NPI.